Hi, my name is Cooper Bailey, and I'd like to talk to you about some of my work regarding density, distribution, and sizes of xenoliths within some of the Eocene intrusions around El Paso, Texas. First, though, let me talk to you about what xenoliths are, why they're in El Paso, and my process in general. Let's start from the beginning. During the Eocene, magma began propagating through the El Paso region, and as this magma came up, it chipped away at other older rocks along the way. These chips, so to speak, were then enveloped into the magma as it cooled, becoming xenoliths. Fast forward 30 million years, and here we are today with andesite formations sat at the surface, full of these xenoliths. Looking quickly here at Figure 1, I chose to focus my research around the Three Sisters, Coronado, and Thunderbird outcrops, which you can see here circled. The xenoliths have some variation, but in general, we're rich in plagioclase with biotite, amphibole, and trace quartz also present. And you can see it here highlighted in the ternary diagram just to get a gist of what we're dealing with. But for this project, however, I chose to only record xenoliths of diorite, monzodiorite, and anorthosite as they were the most common and easily identifiable. My method was to follow transects through each of my outcrops and section off square foot exposures of bedrock before counting up the xenoliths and recording their respective sizes. My average site would have looked something like what we see here in Figure 2, where you might even be able to make out some of the diorite here in the bottom left. But before going into the results, I'd like to take a second and talk about the Three Sisters outcrop. As the name may suggest, there are actually three different hills that compose the outcrop, one of which, the South Sister, has been mapped previously, and it was suggested that there was actually two different suites of andesite separated by a layer of shale. So with that said, I recorded my data assuming that there were in fact two different suites, and just to put the theory to the test. As for my results, we'll start with the density differences. Looking here at Figure 4, we see the average number of xenoliths per square foot between the different outcrops. The South Sisters upper suite is notably high with an average of 13.5 xenoliths per square foot, more than double that of the lower suite. The rest are fairly consistent though, being between 2 and 4 xenoliths on average. Moving on to xenolith distributions, and here's where things start to get interesting. Since the South Sister is presumably two separate suites, and since the South Sister's upper suite has double that of the lower suite, one might imagine that they might also have different distributions. Well, we see here in Figure 5 that this is indeed the case. Here we have the average distribution per square foot of monzodiorite, then anorthosite, then regular diorite, with the upper suite in blue and the lower in green. We see that the upper suite has around 3 times more anorthosite and more than 10 times diorite. This leads me to my first conclusion that the two suites of the South Sister are in fact unique from one another and are even likely from separate sources. Furthermore, since the two suites are on top of one another and they are different, we can assume that there was some sort of lateral emplacement for it to be that way. Looking at the distributions of all the suites here in Figure 6, we start to see a trend. We see that the South Sister's lower suite, the Middle Sister, and the North Sister all share relatively similar distributions of xenoliths, with the blue being monzodiorite, the green being anorthosite, and the brown being diorite. Furthermore, the Coronado outcrop also resembles this distribution. This is in contrast to the Thunderbird outcrop, which we can see here is disproportionately composed of anorthosite in comparison. Finally, I'd like to talk about some of the size data that I recorded. In honesty, I thought this data was going to play a much bigger role in differentiating the outcrops, but as we can see here in 7, the average sizes remain fairly consistent across the board. Of course, there were exceptions, like we can see here in the South Sisters upper suite, with the largest xenoliths being over 70 millimeters in diameter. But however, I'd say all this data was kind of inconclusive. It didn't really help that much, and it was just too varied to really be helpful. So what can I say about all this data to wrap things up? Well, given everything, I can say with confidence that the South Sister is in fact composed of two separate suites of andesite, and that compositionally they are different with regards to their xenoliths. The evidence also suggests that there was a lateral emplacement for it to be that way, at least for the upper suite. I can also say that the South Sister's lower suite, the Middle Sister, and the Coronado outcrop all are similar enough that they may all be from the same source. This is in contrast to the Thunderbird outcrop, which seems to be entirely separate. As for some closing words, all this data has suggested quite a bit, and I believe all of it needs further study if we were to prove any of my theories. This further study is something I greatly look forward to and hope to see the results of sometime in the future. I'd like to say a special thanks to the University of Texas at El Paso. They were really helpful. The mentors and advisors were all really great. Of course, the National Science Foundation for funding the projects, and Central New Mexico Community College for providing me the resources to finish my work when I got back to Albuquerque.